Hi everyone. In this video I'm going to talk about a basic overview of Algebra 1A topics, and the categories will range from operations with integers all the way up to solving and graphing absolute value equations and inequalities. So with that, let's go ahead and begin. Oh, I should also mention to viewers who may not be familiar with the acronym for LT. LT stands for Learning Target, and in this video we are going to cover a total of 4 learning targets, the first one being operations with integers. So with that, let's go ahead and begin. This first question here involves a series of numbers that we have to combine. And when I look at this, I can see right away that these two negatives will become a positive, and so will these over here, because the opposite of a negative is a positive. Now I do need to rewrite this, so it's now negative 6 plus 6. This is still minus 8, and this is now plus 11. Now when you combine these, you want to go left to right, and you want to take 2 numbers at a time in doing so. So negative 6 plus 6 simply becomes 0. This negative 8 plus 11 becomes a 3 when you combine them. And so we have basically 0 plus 3, and so the answer is just 3. The next question involves multiplication. Now when you multiply, you really should take it 2 numbers at a time, and there is a little strategy to this. So when multiplying, it is a good idea, and this is purely based on opinion and just observation from students having used this before. But it's a good idea to use this face. It looks kind of like the Pringles face. And the way it works is like this. So if I take the first 2 numbers, negative 6 times 5, and I multiply them, I have to conceal on the face the 2 signs that I have going on. So a negative 6 means I hide the negative, and a positive 5 means I hide the mouth. Now, as you can see, I have only the I left. So this means that I'm going to get an answer of negative 30, or a product of negative 30 for the first 2 numbers. Then I can proceed in one of 2 ways. I could either now multiply this by my negative 8, and then multiply that answer by negative 9, or I could multiply negative 8 to negative 9, and that would make 72, and then I could multiply that with my 30. There are many different ways to approach it from this point. Just know that when you multiply, order does not matter. What matters is the way you handle the signs of your integers. So I'm going to take the second approach, where I multiply the negative 30 with the positive 72. And once again, if I were to conceal one of the eyes and conceal the mouth, then what I get is a value that is negative. And if you multiply 30 with 72, this would make an answer of negative 2,160. And so that would be my answer. Okay, let's go ahead and move on. This question is relatively simple compared to the last 2 that we looked at. This is just simple division of 2 digits. One thing to note here is that you still want to use this face. This face is good for multiplication and for division, but it does not work with addition and subtraction. So that's something important to note. So when I'm dividing, or when I'm multiplying, and I have 2 values, I want to cover the signs of each value on the face itself. So I have 2 negatives, therefore I cover both of the eyes, and I get a positive value. And it turns out 60 divided by 5 is 12. So my answer is positive 12. Okay, in this next question, we are being asked to evaluate. Now, evaluating simply means simplifying an expression down to as far as you can, down to usually a single value, or a smaller expression that cannot be broken down anymore. Now I'm told that the value of my x is 5 and the value of my z is negative 2. And what that means is that anywhere I see an x, I will make it into a 5, and anywhere I see a z, I'll make it into a -2. So this is called substitution, and in doing that, you want to be careful, especially when you have negatives involved, like you do right over there. You want to be careful when you substitute that if you have other negatives in the picture, that they don't interact with each other right away. You want to set it up and then go from there. So I have 5 minus 1 minus, parentheses, I keep the format the same. This is -2 minus 3. And then I have, as you can see, plus the value of my z, which is -2. So it becomes plus -2, and I put that in parentheses. And now this is, from this point on, it's order of operations all the way to the end. And the way you want to proceed from here is by doing what's inside parentheses first. So this would be in -5. So I'm going to scoot this over a bit. So I have 5 minus 1, and then I have minus -5, and then plus -2. Okay, so going back to the beginning, I can combine 5 minus 1 to make 4. And you can see over here that I have a double negative, which is going to become a positive. So I need to rewrite that part. And this will now be 4 plus 5. This plus -2 that you see over here, plus -2 is simply like saying minus. And the reason can be explained in different ways, but one way of looking at it is that your value to the left of the positive sign, whatever that is becoming more negative. So the plus means more, the negative means negative, so more negative. Or you can think of it as simply, you know what, this is positive times negative, which is always a negative. So however you want to think about it, this is now simply -2. Now 4 plus 5 is 9, 9 minus 2 is 7, and that is my final answer. All right, let's move on and look at the next question. So in this question, what I need to do is a couple of things. This is a task involving distribution and combining like terms. When you distribute, you want to be sure to include not only the number itself, but the sign of the number, especially when it's a negative. You want to be sure to include that with the number, because it is a package deal. So it's -6, not just 6, times 5n. So that would make -30n. Now you multiply the same -6 with the 3, and that makes -18. Next is the -4, and yes, this minus sign here makes the 4 a -4. So you're multiplying a -4 inside, and now this is -20. -4 times -6n, pardon me, is positive 24n. What you want to do now is you want to seek out any possible like terms. Like terms are terms that share the same variable and exponent, and the exponent has to be placed in the same way between the terms. So I can see over here that I have a term with an n, and I have another term with an n. These two are going to join with each other. Excuse me. At the same time, like terms are also those that have no variable. They're just integers by themselves with no variable. And it turns out that this one and this one share that trait. So because neither of them have a variable multiplying to it, these will combine with each other. So if I put the green ones together, this is -30 n plus 24n, and then the pink ones become -18 and -20. So if I were to organize this, then what I would get is the following answer. This becomes -6n, and -18 minus 20 becomes -38. And this would be the final form of the answer, -6n minus 38. Okay, let's go ahead and move on to the next one. We have a word scenario here where we have to pull out information and write an expression. So let's go ahead and do the readout first. So Mark went to the store. He had to pay $13 for parking. While he was at the door, he spent $2 per pound for bananas and $3 per pound for trail mix. On the way out, he donated $5 to the Girl Scouts. So our task is to write an expression that represents the total amount of money that he spent. So total amount of money that was spent. We have to also define the variables that were used, and then we have to finally simplify the expression. So we have 3 tasks that we have to accomplish here. Whatever I circled is what we have to do before we can say that we are done with this question. So let's first identify what's important from what we read. So he had to pay $13. This is a one-time payment. He pays it, he parks the car, and he's good. Now, when he was at the door, he spent $2. He spent $2 per pound for bananas. Because we're not told how many pounds he actually bought, we need to represent this with a variable. And then $3 per pound for trail mix. So he bought 2 different items. We're going to use a variable representing the amount of each item that he bought. And then lastly, he donated $5. So we have a total of 1, 2, 3, 4 amounts that he spent. And so we're going to represent the expression like this. It's going to be 13 plus $2 per pound of bananas, so I'm going to call bananas B, plus $3 per pound of trail mix, so we're going to call trail mix M for mix, and then he finally spent $5 as a donation to the Girl Scouts. That's our expression. And in order to answer this part where we define the variables, all we have to simply do is say what our B represents. So I can easily do that over here and say, I want B to represent pounds of bananas. And I want the other variable, the M, I want that to represent pounds of trail mix. Trail mix. Okay? And now we have to simplify the expression. Actually, the best way to do this probably would be to take the 13 and the 5, combine them together. So this would be, as a final expression, this would be 18 plus 2b plus 3m. Okay, and that would be the end. All right, let's move on to the next one. Let's see. Oh, yes. So now we're leaving Learning Target 1 and we're going into Learning Target 2. In Learning Target 2, we deal with solving, justifying, and checking equations. So let's go ahead and jump right into this. What I like to do to solve is first create a partition between the left and right sides of the equation. The reason I do this is because psychologically, it helps the brain to understand that there's a left side and a right side. And when, especially combining like terms, it avoids confusion with trying to combine things that are on opposite sides of the equal sign. So the first thing that you want to do is you want to distribute that -2 inside. So this becomes the following. You get -6n minus 6, and then you have -7n. This positive 8 distributes as well, and you get plus 8n minus 48. Okay, now you look for like terms. The like terms will be, or should be, on the right side if you're able to combine them. So I can see over here that I have 2 terms which could be combined, and both of them share an n. So I'm going to go ahead and combine those together. That's going to make just a single n minus 48. And on the left side, -6n minus 6 cannot combine because this -6 does not have a variable. All right, so what I need to do now is realize that this n and this term with an n need to join together, but they cannot do so unless they are on the same side. Which side they end up on does not matter. What matters is that they end up on the same side. So you have freedom to choose where you want to move your terms. So either you can move this n over there, or you can move the negative 6n over there. What it comes down to is what you think is easiest and most convenient. Otherwise, it makes no difference at all. So I'm going to go ahead and move my n value by subtracting n and placing it there. These two eliminate, and what I get is negative 7n minus 6 is equal to negative 48. And then continuing to solve, now that I've decided that I want to move my variables to the left side, that means I now need to move all my values, my numerical values, to the right side. So I'll begin with the inverse of negative 6. These two eliminate. What I get is negative 7n is equal to negative 42. And if I were to divide this equation by negative 7, what I get is the answer that I want, which is n is equal to positive 6. That's my value. Okay? Now, the justifying part happens when you explain what was done at each level. Now, just to be very clear about this, I am going to adjust some of the coloring that I used so that I can accurately justify what I did from beginning all the way to the end. So the first thing that was done, the first step that was done was distribution. That was the first step. So I'm going to justify the first step, and maybe I'll do it this way, just so that everything happens at the same level. First step I did, right over here, was distribution. Okay, so I'm going to describe everything I did in pink as a step for breaking this equation down to its final form. So distribution was the first step. Next, right over here, was I combine like terms. Then I use what's called the subtraction property. That's when I subtracted n on both sides. Then I use the addition property. And finally, I use the division property. So addition property, then division property. And with that, we reach the final form, which is just the answer, n is equal to 6. Okay, so I solved it. I explained how I did it by justifying each step along the way. And now I need to check my answer to make sure that I actually did all this correctly. Because after solving, if you walk away and you don't check to verify that your solution is actually correct, then you might be walking away from something that is wrong. So let's go ahead and get to how to check this. So I'm going to get rid of all that. To check an answer is quite simple. All you have to do is take the answer that you have. So in my case, the answer was n is equal to 6. At least that's my claim. This is my claim. And so I need to check it. To check it, you simply replace all the variables with the number that you think that you're claiming is the answer to this. So this becomes the following. Negative 2 times 3 times 6 plus 3 is equal to negative 7 times 6 plus 8 times 6, and finally, or I did this wrong, 6 minus 6. Okay, so use order of operations to break this down, and order of operations always says go inside the parentheses and do what's there first. So I'm going to find the easiest place to simplify, and that would be right over here. So this 6 minus 6 simply becomes 0. So that means that this whole term is also gone, because 8 times 0 would be 0. On the left side, what I get is still negative 2, but this is now 18 plus 3. And on the right side, I get negative 42. Okay, so now the most work I need to do is now on the left side, since the right side is just a single number. So I combine what's inside, 18 plus 3, and I get negative 2 times 21. And then I multiply negative 2 times 21, and I get negative 42. The meaning of this answer is that I have a reflexive property here. Because it's reflexive, it is evidence that the answer I got, which is positive 6, is the right one for this equation. So when you use a 6 on both sides with the variables being replaced by the 6, and you break it down, what you end up with is a true statement. You get the same value on both sides of the equal sign, and that does justice to the equal sign being the same thing. It means the same thing. And indeed, these two numbers are identical. So that's how you know all your work paid off. Okay, let's go ahead and move on to the next question. So in the next question, we have a word scenario once again, and we're going to do a quick read through. So here we go. So 2 video game stores are holding a sale. Yes. Store 1 is charging $10 to get in and $3 per game. Store 2 is charging $15 to get in and $2 per game. That's a pretty sweet deal if you ask me. $3 a game, count me in. What we have to do is write an equation to find out how many games you have to buy. So how many games you have to buy so that you spend the same amount at each sale, at each store. So let's go ahead and do that. So we have store number 1, store 1, and store 2. In order to find out how many games you have to buy so that both stores come out to the same amount, you set them equal to each other. And you simply have to build an expression for each store, and then you have an equation from that, and then you can solve it. So we're going to say that G is equal to the number of games, because the total that you spend depends on how many games you buy. And for store number 1, we have $10 to get in plus $3 a game. And then for store number 2, we have $15 to get in plus $2 per game. And now we have an equation that we can solve. So to solve this, again, you want to juggle things around, bring the variables together on one side, push the numbers to the other side, and it doesn't matter on what side the variable ends up. If you're comfortable working with negatives, then you can just push it to either right or left side. So to demonstrate this, I'm going to move my 3g over to the right side by subtraction. So here we go. It's going to be minus 3g, and then these eliminate. What I get is 10 is equal to 15 minus g. And then since I've decided to move my g's to the right, I'm going to move all the values, numerical values, to the left side. So I subtract 15. These eliminate. What I get is, if I bring it over there, I get negative 5 is equal to negative g. And what I need to finally do is realize that, hey, there's a negative 1 there. That's multiplying, so I need to divide it out. So when I do that, what I get is g is equal to 5, or 5 is equal to g, same thing. So now we have to explain, we have to interpret the meaning of the solution. So we solved it, so check that off, but we have to now explain what the answer means. And a good rule to go by is when you do word scenarios, end your answer with words. So you want to connect your numerical answer back to the story by using words yourself. Otherwise, the number alone makes no sense, and it's just a dead answer. So let's go ahead and make that connection here. So the whole thing was about how many games you have to buy so that the amount you spend at either store is the same. And it turns out if you buy 5 games at either store, store 1 or store 2, your total amount walking out the door would be exactly the same. So if 5 games, that looks terrible. So if 5 games are purchased, comma, the totals at both stores will be the same. All right, let's go ahead and move on to the next example. So in this question here, we're dealing with inequalities, and inequalities, the solving of inequalities mimics the patterns and techniques for solving regular equations. The only difference is that in the end, we have to graph the solution, and the graph of the solution and the solution itself represents an idea that is different from that of standard equation. So let me go ahead and explain by doing this one question here. So the first thing to do, or the first thing that I'm going to do, is I'm going to distribute this -3 inside. So it's the same technique as with solving equations. So this becomes -3 plus 6k, and this is greater than -5 plus 8k. So as you can see, it starts off the same way as when we solve a regular equation. Now, I have to decide where I'm going to move my term with the variable k. When solving equations, it doesn't matter on what side it ends up. But when you solve inequalities, it kind of does matter in a way. What I mean by that is, ideally, it's best to have the variable on the left side. And this is strictly for graphing purposes, but it's also because it is easier to interpret the meaning of a solution when the variable is on the left. So my emphasis in solving this will be to bring the variable to the left side. So with that, here we go. So I'm first going to divide this, just because I like to have that division, as I said before. And to move the 8k, I'm going to do the inverse. So subtracting 8k from both sides. These two eliminate. And I get -3 minus 2k is greater than -5. Okay, so now that I've decided I want my variable to be on the left, I'm going to move all the numerical values to the right. And this will begin with moving the -3. So I'm going to do the inverse to both sides. This disappears, and we get -2k is greater than -2. And so what I need to do now is divide by -2 in order to isolate my k. And this is where things kind of get interesting. So these eliminate. Here I get a 1, but because I divided both sides with a negative number, in other words, I divided using a -2, dividing by a -2, or a negative number, this inequality is going to change its direction. So before, it was greater, but it has now changed into less than. And there are reasons for this. It's not something that I encourage you to simply memorize. There is a logical, rational explanation for why this happens. Unfortunately, I will not cover it in this video, but I encourage you to do the research yourself and look into why the inequality has to reverse. And if it doesn't, then ultimately the answer will look correct. The graph will look correct, but everything will be wrong at the very end. So now we're at the end. This is our solution. And what this means is that the value of k can be any number you want it to be, with the condition that it is a value less than 1 or smaller than 1. That's a condition. So if you meet that condition, you can pick anything in the known universe of numbers for k to be, as long as it's not something that is 1 or bigger. It can be anything less than 1. So the way to represent this on a graph is you go to the number 1, which is right here on the number line, and then you represent that location, in this case with an open point, an open circle. The reason for this is because with less or greater, you always have an open circle. Less or equal, greater or equal, you have a closed circle. The reason that you close it is due to the equality part built into the inequality itself. So that equality part allows you to include the number that the dot is sitting on. So in the absence of that equality, you have to leave that circle open. So getting back to the graph, we go to 1, and because I want numbers that are only smaller than 1, I must go left. And that represents all possible numbers that I could pick for k to be on the left side of 1. Okay, that's the end of this one. Let's go on to the next one. So here we have what's called a compound inequality. And a compound inequality is it's a combination of two inequalities working together simultaneously. And there are two outcomes for this. One is called a conjunction, the other one's called a disjunction. And the way that you can tell which one you have is by looking at the word that you are given. So when you see the word or, this represents a disjunction. Okay? And ultimately in the graph, you'll see why that is. But the way to do this is you first take one set of one inequality, you solve it, and then you take the other one and you solve that, and you'll have two answers which you can then graph together at the same place, which is on this number line you see here. Okay, so with that in mind, let's go ahead and do the solving part. So we have 6a plus 2 is greater than 20. And then we have, on the other side, we have 7 minus 10a is greater than 77. So in order to solve this, I just have to use my equation solving skills. So I'm going to subtract 2 on both sides. I get 6a is greater than 18. And if I divide by 6, the value of a is anything that is greater than 3. Okay? Now on the other side, if I subtract 7, what I get is negative 10a is greater than 70. And if I divide by negative 10, then I have to remember what happens when I divide by a negative number. So this inequality is now going to face the other way. It was less, now it was greater, now it's going to be less. So I have a could be any value as long as it's less or smaller than negative 7. So I need to graph both of these together on the same number line. And the way to do that is you go to these two focus numbers, which are 3 and negative 7. And that would be right here. So at 3, I have an open dot, and at negative 7, I have another open dot. Now, when you're at 3, you want numbers that are only greater, which means you have to go to the right of 3, because that's the only direction where the numbers become increasingly bigger than 3. When you're at negative 7, you want values that are only smaller than negative 7, which means you must go left, because going left on a number line means that your numbers are becoming, your values are becoming smaller and smaller and smaller. And so going back to why this is called a disjunction, it's a disjunction because these two graphs are independently disconnected. They're disconnected from each other. So disconnected, this idea of disconnection is built into the word disjunction. Okay, and they go in opposite directions. And that also accounts for why you have the word or here, because if you want to choose a value for a that satisfies these inequalities, you must go in either the right direction or the left direction to choose your values. Nothing within this space over here, nothing within this space here will work. This is out of bounds. It's off limits. So if you take something from there and you try it on either inequality, it will fail. And that's why you have this option of going right or left, right or left. Okay, let's move on to the next one. So this one is different from the previous question in that we don't have a word like or to sort of guide us in knowing how this is going to end up. But what we do have is an interesting setup. It looks like we have a combination of inequalities that have been sort of smashed together into this one. And so there are different ways of approaching this. One thing that I have seen is this is broken up into first solving this part and then solving this part over here and graphing both of them together. But I want to show you another way. Okay, so I'm going to bring this over here like this. And this is how I'm going to proceed from here. So what I'm going to do, like before, is I'm going to divide this up. Okay, usual thing. So I'm going to try to empty out the middle, and I'm going to try to isolate the x in the middle. So moving all the numerical values from the middle to the right and left, I start by adding 7. When you add 7, normally you do it to the left side and then to the right side. In this case, we have a middle, we have a left, and we have a right. So I'm going to have to add 7 here, there, and also right there. So these two cancel. And now I have to rewrite what I have. So I have 8 now on this side, negative 2x, less or equal, and this is now 20. The next thing to do would be to remove that negative 2 from the x. So I need to divide negative 2 here, repeat it here, and repeat it there. So the negative 2's in the middle eliminate, and what I get is negative 4 and negative 10 and x. But remember, when you divide with a negative number, or you multiply both sides with a negative number, the inequality reverses its direction. So this over here is now going to change, and this over here is also going to change. So they are now going to face in the direction opposite of what they were before, like that. Now, before graphing, because my x is isolated now, but before graphing, what we now need to do is one other step, which is we have to take this and create a conditional statement, which is an if-then statement. And what I mean by that is this. I'm going to say if negative 4 is greater than x, then that means that x is less than negative 4. And this is the form that I want to graph from. Okay, the variable must be on the left when you're graphing, otherwise you might not get an accurate graph. So that's why I did that conditional if-then statement. Helps me to reverse everything in the correct way. So that is ready to go. Now the second one, which is this, has been ready to go, and it was just waiting for the other half to turn itself around. So now I can go ahead and graph this. So I'm going to go to negative 4 and then negative 10. So at negative 4, I have an open dot, and at negative 10, I have a closed dot. So when you're at negative 10, you want values of x that are either negative 10 or bigger. So that means that you need to go to the right. When you're at negative 4, you want values of x that are only smaller than negative 4. Not negative 4 itself, just smaller. So that means you need to go left. So what happens eventually is that these two simply join together. And what they create is something that's called a conjunction, which is the opposite of disjunction. And the idea for conjunction comes from these 2 points being connected together. So connected, conjunction. And so any value for x that you want to pick must come from between negative 10 and negative 4. You could use the number negative 10 itself if you wanted to, but you could not use the number negative 4 because the dot is open above that number. Okay, and that would be it. So let's go ahead and move on. A word scenario. Okay, so let's go ahead and do what we did before. We're gonna, I'm gonna do a read through and then break this thing apart into what's relevant. So here's our task. We're gonna write, solve, and then interpret an inequality for this scenario. So here we go. I need at least $100 to go to prom. I already have $45 and plan to save $10 per day. How many days will it take for me to have enough money? Well, the information here is pretty clear. So at least $100 is going to turn into greater or equal to 100. The reason for that is when you're saving money, people usually want a minimum of a certain amount. And if they save more than that, there's nothing wrong with it. In fact, it's usually better to save more than your minimum, the minimum that you need. So, so if she has $100 or you have $100, you can go. But if you save $500, well, that's even better because now you have more cash to do more things with. So you started with $45 and you increase this by $10 per day. And I'm going to use D for days. So D equals days. Okay, so here's our inequality. What we have to do is figure out how many days it will take for me to have enough money. So I need to solve this. And solving by this time, hopefully, has become a lot easier. So I'm going to subtract 45 from both sides. And what I get is 10D is greater or equal to 100 take away 45 is going to be 55. Now, if I divide both sides by 10 here and there, what I get is the following answer. What I get is D is greater or equal to 5.5. Now, I need to make sense of this, right? So we have to now interpret. We wrote, we solved, and now we have to interpret the meaning of our answer. The question was, the focus question was, how many days will it take for me to have enough money to go to the prom? So if we're talking about days, 5.5 means 5.5 days. So to summarize this, I need to save for 5.5 days or longer in order to have at least $100. Okay, so if you save for, let's say, 10 days, you'll have more than $100 and you're good to go. All right, let's go ahead and move on to the next one. All right, so we're in the next and final learning target. This is LT4, absolute value. And there are two questions, I believe, that I'm going to demonstrate for you here. The first one is an absolute value equation. One quick thing to note is that absolute value has to do with the distance, the measurable distance in steps from zero, right? So it's the number of steps away from zero. And that can go in either direction, positive direction or negative direction. Now, the way to do this, the way that I like to do it, because there are other ways to do it, the way I like to do it is I like to approach this using the same skill set that we use to solve regular equations that are not absolute value. So the first thing I have to do is understand that these bars here, the absolute value bars, are impenetrable. What that means is that you cannot distribute inside of it. So I cannot do this like I do with parentheses. That's not going to work. Also, I cannot remove anything from inside. I can't just pull it out. So I cannot do this. I cannot do that right away either. That's not going to work. Okay? These walls are absolutely strong, absolutely tough. And so there has to be another way. So the other way to do it is remove anything outside the bars first. And you want to be careful how you do this. One thing that I commonly see is people put these together and they make 5. That is incorrect. The reason it's incorrect is because this -5 is actually multiplying against the absolute value. So it is, even though it cannot distribute inside, it is still being held against it by multiplication. And so I have to consider that when I'm trying to work with it. Because subtraction and multiplication are not opposites, I cannot simply combine those and make 5. So the way to do this is you first want to remove this 10 over here. And the way to do that is you subtract it. So subtract 10 on both sides. And what you get is -5 times the absolute value of 10k plus 4 is equal to, and this is now -70. Okay? Now, this -5, as I said before, is multiplying, and the opposite of multiplication is division. So the correct way to deal with this -5 is to divide it, because that operation is the opposite of what's holding it together to the absolute value. So I divide by -5, this goes away, and then what I get is absolute value of 10k plus 4 is equal to, these two numbers divided is going to be 14, positive 14. Okay, so now I have to ask an important question, and the question I need to ask myself is, what number is 14 spaces from 0? That's the question I need to ask myself. So if I were to ask anyone, what number can you think of that is 14 spaces away from 0? There are two possibilities. If you look at a number line and you consider 0, if you go 14 spaces to the right and you stop, you're at positive 14. And if you go 14 spaces to the left and you stop, you're at negative 14. Okay? So the answer to the question, what number is 14 spaces from 0, would have to be both 14 and negative 14. Both of these numbers are the correct answer to that question. So I have to represent that in this way. I need to write, I'm going to switch back to black over here. So I'm going to write negative 14 and positive 14. Okay, my goal is to figure out what value of k, so what number could I multiply with 10 and then add 4 to make negative 14. So what number, oops, wrong color. So what number times 10 and then plus 4 will make negative 14? And on the other side, what number times 10 plus 4 will make a positive 14? Again, this idea is coming from the notion that negative 14 and positive 14 are each 14 spaces away from 0, right? So what we're trying to do is figure out what value of k will create those two numbers, which are each 14 spaces away from 0. So now we have two independent equations that we have to solve, and once we do, we're done with this thing. So I'm going to go ahead and do that. So I subtract 4 on both sides. That goes away. Those go away. And then I have 10k is equal to negative 18. If I divide both sides by 10, okay, I'm dividing both sides by 10. I'm not writing that down, but this is the operation I'm doing. So dividing both sides by 10, what I get is negative 1.8. That's my first answer. The second answer would be, let's see, 10k is equal to, this is going to be 10, And if I divide both sides by 10, what I get is a friendlier answer, which is k is equal to 1. And with that, this question is answered. Okay, so the two values of k would be 1 and negative 1.8. All right, let's move on to the final question over here. This is an absolute value inequality. This is combining whatever we did with solving regular inequalities and graphing them and understanding the solutions, and also absolute value equations and the principles behind solving and understanding what they mean. So with that, let's go ahead and begin. So this is the final question that I'm going to answer, and I'm going to bring this down over here just so that my work is more organized. I don't want to cut through that number line there. All right, so divide this down like that. Okay, so as I said before, you want to eliminate anything outside the absolute value. So you don't want to take that negative 2 and distribute it. That's not going to work. You don't want to subtract 9. You can't pull anything out of there. And you definitely don't want to divide by 6 right away. You cannot do that either. So what you want to do is eliminate everything outside. So I'm going to start with this 3. These go away. And what you get is negative 2 times the absolute value of 6n plus 9 is greater than negative 66. So now I have to divide by my negative 2 on both sides. And what I get is, the absolute value of 6n plus 9 is less than, again, this inequality had to turn itself around. It had to change into less than because I divided using a negative number. And this becomes 33. Okay, so now this is where it's a little different from the previous question that I did, because now we have to think in terms of not only distance from 0, but we have to think in terms of inequalities as well. So what this question is asking from this point, what it's really saying is what number or what numbers are less than 33 spaces away from 0. So if you want it to be less than 33 spaces away from 0, you want it to get closer to 0. You're trying to get closer to 0 because you want to be no more than 33 spaces away, right? So if you want to be less than that, then what are your limits? What's the farthest away from 0 you could go in either direction, positive and negative? And so the answer to that would be, if I draw a number line for you, you might be able to see it better. So here it is. So if here's a number line, and if this is 0, and you want to be less than 33 spaces away, that means you want to be as close to 0 as possible. Your limits are 33 and negative 33. That's as far out as you're allowed to go. Because if you go beyond 33 or negative 33, if you go beyond those two numbers, you now violated this inequality, and you're now farther away than you're allowed to be. So, and one more thing is, because this inequality has no equal part to it, we have to think of this as not including 33 and negative 33 itself. Okay, so you can be anywhere in between, and you're safe. You're less than 33 steps away from 0. So with that in mind, we're going to take our limits. So the negative 33 and the positive 33, and we're going to write them down as follows. So we're going to have negative 33 and positive 33. And then you want to think to yourself, all right, so if I'm at negative 33 and I want to be closer to 0, do you go right or left? And the answer is, well, I would have to go to the right. Okay, going to the right as you can see from the tip of the arrow, would mean a greater than sign. So then I take the 6n plus 9, and now I have an inequality I can solve. If you're at positive 33, and you want to get closer to 0, then you'd have to go to the left. And if you pay attention to the tip of that arrow, that would be a less than sign. And so now we have 6n plus 9 is less than 33. And now we have two independent inequalities that we can solve and then graph together in the same place. So if I subtract 9 on both sides, what I get is 6n is greater than, this would be negative 42. Keep in mind that I am subtracting 9 on both sides. That leads me to add negative 33 minus 9. That's why I got negative 42. Then if I divide by 6, I get n is greater than negative 7. First answer. Second answer, if I subtract 9 on both sides, I get 6n is less than 24. And then if I divide by 6, I get n is less than 4. That's my second answer. So now, what I do is I go to these numbers on the number line, and I put my points, and I make my graph. So I go to 4, put an open point, go to negative 7, put another open point, and then I have to consider which direction to go from each number. So if I'm at negative 7, as you can see from the answer over here, so if you're at negative 7, n has to be can be anything as long as it's bigger than negative 7. Bigger means I must go to the right. So there I am, going to the right. If you're at negative 4, if you're at 4, then n could be anything you want it to be as long as it's smaller than 4. So smaller than 4 means you have to go left. And then if you look at this this graph, what we have is what's called a conjunction. So conjunction, coming from the word connected, meaning that any value that you want to pick from this graph must come from between negative 7 and positive 4. But because the points on these numbers are open at both ends, you cannot use 4 or negative 7 themselves. But anything in between would be absolutely fine. And with that, we have reached the end of the video and of the review of learning targets 1 through 4, covering integer operations all the way up to solving and graphing and understanding absolute value equations and inequalities. I appreciate your time. Thanks for taking time to watch. And as always, if you want to leave a comment, please make it constructive. I love to know how I can make my videos better, and your feedback really, really helps. All right, thanks for watching. Take care. Bye-bye.